This week on the show, we are covering a tutorial about running AIX on QEMU on Linux on Windows. And if you're now confused, that's part of the story. We also cover your NAS Fleet with TrueCommand. We have Unleashed 1.3 operating system available. The LLDB CPU register inspection support extension has been added to NetBSD. And also a story about vSystem Unix programs often not written as expected, and more in this week's episode on BSD Now. BSD Now, episode 300-1, the NAS Fleet, recorded for the 22nd of May 2019. Hello, I'm your host, Benedikt Reuschling.
And I'm Alan Jude.
Welcome to this almost 300 episode. We are almost there, but this is 299. We're getting there. And of course, as always, we bring you the headlines for this week. The first one is running AIX on QEMU on Linux on Windows. Are you following?
This is fun. I remember doing something kind of like this. One of my first machines where I dual booted Windows and FreeBSD. So I had the hard drive split in half with half Windows and half FreeBSD. Because it didn't have a CD-ROM drive, I didn't have an easy way to install FreeBSD because I don't think USB sticks were really a thing yet. Like the USB stick I had was 128 megabytes, so it couldn't hold a FreeBSD install.
Yeah, CDs were the thing.
I ran QEMU under Windows with the second partition as the backing disk and installed FreeBSD from Windows using the ISO file. Then I would boot FreeBSD and inside of that use QEMU to run Windows for the one app I need Windows for.
As one does.
So I had in Windows you used to be able to set up different hardware profiles because basically you needed different drivers for QEMU than you did for my real hardware. And so when the machine powered on, you could choose Windows or FreeBSD. And when you booted FreeBSD, you had to choose real hardware or the VM drivers, and then it would boot. And so I could run Windows and run FreeBSD as a VM, or run FreeBSD and run Windows as a VM. And it was kind of fun. But not as much fun as this, which is apparently using the Linux subsystem for Windows to then compile QEMU from source. They're using the Debian flavor of WSL, and then running AIX in the QEMU in the Linux subsystem on Windows.
Okay. Of course, this is over at Virtually Fun. And yeah, this is what you can do. Not that it makes sense, but it's possible.
Yep. Yeah, so they download the binary packages for the build essentials and the dependencies for QEMU. Then they grab, I guess, this branch of QEMU that's been set up for Windows, maybe, and they configure it to do PowerPC with a software MMU, and configure and compile that. And then they create an empty 8 gig disk for AIX, grab the open firmware to boot it with, and then now they can run the QEMU PowerPC, which will translate the instructions to the x86 that they're actually running on. And they get serial console running on port 4441, booting that QEMU hard drive. And then they provided the CD image for AIX and installed it.
And here it boots and can be installed. Yep. Wow. Never seen it before, but I guess I didn't miss much. Oh, wow. Okay.
Yep, so they walk through the install of AIX, and if you thought the FreeBSD installer was annoying,
then, yeah, compared to this.
It took 17 minutes on their Mac Pro, which is a Xeon X5365.
Oh, I guess their fans were spinning.
Or 11 minutes on a newer Xeon E5 2667 V2. That seems long.
Oh, yeah. I guess all these layers
you are
of virtualization.
You are emulating a PowerPC on an x86. So that's not going to be able to take advantage of hardware virtualization. It's pure
Yeah.
software. So actually, that speed makes sense. But if you never got to play with AIX and you want to pretend, then this is an interesting way to do it.
If you're desperate, yeah. All right, the next article that we have might be a bit more interesting because here we take command of your NAS fleet with TrueCommand over at ixsystems.com, their blog. We haven't covered them in a while, so it's high time to get back there. They covered the new TrueCommand here, writing that with hundreds of thousands of free NAS and true NAS systems are deployed around the world, with many sites having dozens of systems. Managing multiple systems individually can be time-consuming. IX Systems has responded to the challenge by creating a single pane of glass application to simplify the scaling of data, drive management, and administration of IX Systems NAS platforms. We are proud to introduce TrueCommand. So TrueCommand is a ZFS-aware management application that manages true NAS and free NAS systems. With the public beta of TrueCommand is available for download now. TrueCommand can be used with small IX Systems NAS fleets for free. Licenses can be purchased for large-scale deployments and enterprise support. And TrueCommand expands...
It works with FreeNAS, so that's just you install that software on any machine of yours. With the FreeNAS Mini and FreeNAS Mini XL, which is you buy their hardware and runs FreeNAS on it. The FreeNAS certified servers, which are certified to work with Citrix and VMware and stuff like that, or their TrueNAS X and M series. One of those is flash only. And all of those will talk back to the TrueCommand, which you can then run on multiple clients and be able to actually monitor all of your devices at once.
Mm-hmm. And so, yeah, the centralized NAS fleet management gives you a lot of things that you just want to have if you have a lot of NAS systems from IX Systems, and that makes it just easier to manage them.
Yeah, so you get the single pane of glass to see everything. You get single sign-on, so you don't have to manually, if you add a new member to your team, you don't have to go and add them to each NAS. Customized alerts and reporting, rapid fault management and diagnosis, real-time data collection, predictive analysis, keeps stats for 2 years, has role-based access control, so it's easy to add people. You can do NAS system groups and assigning different NASs to different teams, has audit logs and so on, so that the logs go from the NAS to the central system so that you can have logs off the system in case it gets compromised or something. And it works with secure deployments, even air-gapped networks.
Mm-hmm. Cool. That seems like a lot of new functionality, or that have been people looking for.
And the community benefit, the TrueCommand with community support is available without any purchase or contract, and can be used for up to a total of 50 drives across multiple NASs. So if you just have 3 or 4 NASs, the small ones at an office or something, you can use that. But if you have a serious deployment with more than 50 hard drives, then you get the expanded license and you get support and so on.
No, that's good. So you can make use of those without buying a license, but you can get also from there into the enterprise licensing if your fleet starts getting bigger and bigger, and so that is the pricing is based on the number of drives and desired level of support.
Yeah, I have some deployments that are over 300 disks. That's not a home gamer setup, so it makes sense that that's where you need a license, and most likely where you're going to want support anyway.
Yeah, and so that makes managing your IX Systems-based NAS systems much easier. Very cool. So, time for news roundup this week. We have Unleashed 1.3 has been released, or unleashed. Haha, big joke. So this is the 4th release of Unleashed, an operating system fork of Illumos. For more information about Unleashed itself and the download links, see their website. And as one might expect, the release removes a few things. And with the most notable being the removal of the Corn Shell 93 along with all its libraries. Okay, so that's gone. And there, as far as libc interfaces are concerned, a number of non-standard functions were removed. They list them here. So I don't think we have to list them here. So it's on the announcement.
On the website, they say that Unleashed is intended as a modern Unix operating system for developers by developers and comes with ZFS, dtrace, crossbow, and more.
Yes. So people who are want those features can have a look at that. And yeah, they have a nightly.sh, which is no more in this release. In short, to build one simply runs just make, and there's a README for detailed build instructions.
Yeah, and so on the website, they have a little why they forked from Illumos. The first part is they wanted to, stock Illumos still depends on some closed source binary blobs and stuff like that, and they wanted to replace those. They wanted a complete installable operating system, whereas Illumos is kind of the base for someone to build a distro from. It isn't actually a distro itself. They wanted to have periodic releases every 3 months. They wanted to provide or have no uname identity crisis. It always says Unleashed instead of Illumos claims to be SunOS 5.11, despite that actually being different than Solaris 11. They're modernizing the system through the removal of a lot of legacy stuff, where went binary incompatible with Solaris, which allowed us to remove a lot of the cruft. Results may break ABIs, but everything can be recompiled. And they're moving towards sensible defaults instead of retaining API backwards compatibility forever. On Illumos, the default compilation environment is ancient, and you must specify arcane compiler flags or link with additional libraries if you want anything newer. Whereas they want their configure script to be enough for most software. And we have, So they describe some of the differences from Illumos.
Mm-hmm. Okay, so in case people want to check it out, then you can find that on unleash-os.org. Next up, we have LLDB extending the CPU register inspection support over at NetBSD blog.
Upstream describes LLDB as a next-generation high-performance debugger. It's built on top of the LLVM and Clang toolchain and features great integrations with those. At the moment, its primary support is for debugging C, C++, and Objective-C, and there is interest in extending it to more languages. Back in February, Michael Gorney said that he started working on LLDB by contract from the NetBSD Foundation. So far, he's been working on re-enabling continuous integration, squashing bugs, improving NetBSD's core file support, and updating NetBSD's distribution up to LLVM version 8, which is currently stalled by some unresolved regressions in the inline assembly syntax. See his March 2019 report for that. Anyway, it says, in April, my main focus was fixing and enhancing the support for reading and writing CPU registers. And he has a short summary of their BuildBot status as they work through that, and then working on the register support. So the first task was to fix a bug in the reading and writing of the registers, which were identified earlier. The registers were introduced as part of the MMX extension to x86. So that was quite a while ago, if you remember that. And they were designed as overlapping with the earlier ST registers used in the x87 FPU. For this reason, they are returned by the ptrace call as a single FX87AC array whose elements are afterwards to work for both kinds of registers. The bug in question turned out to be a mistaken use of the FXXMM instead of that FX87AC variable. As a result, the values of MM0 through MM7 registers were mapped to a subset of the XMM0 and XMM7 registers rather than the correct ST registers.
Okay.
He says, however, the fix itself was the easy part. The natural consequences of identifying a problem with the register was to add a regression test for it, and that triggered a whole set of events, which you can read more about in the article here. But they added tests for those registers for 64-bit MMX and the 128-bit SSE. They added tests for the general purpose registers, AX, DX, SP, BP, SI, DI, and separate versions for i386 and AMD 64. Tests for additional 64-bit registers are 8 through R15 and 8 additional XMM registers. Tests for 256-bit YMM registers for AVX and the 512-bit ZMM registers for AVX 512. And then finally, tests for XMM 16 through 31 and so on for the expanded AVX 512. Mm-hmm. They also fixed the memory reading and writing routines so that you can actually modify memory. They found the general purpose registers tests were initially failing on NetBSD. Specifically, the tests worked correctly on the to the point of reading registers, but afterwards LLDB indicated a timeout and terminated the program instead of resuming it. While investigating this, I discovered that it is caused by overwriting the RBP. Curiously enough, it happens only when a large value is being written to it. They bisected it to the appropriate max value that still worked correctly and identified it as being, VM.max address. So it explains. So GDB did not suffer from this issue. I've discussed it with some people from LLVM, and it might be actually related to the unwinding of the stack. Upon debugging it further, we've noticed that the LLDB-server is apparently calling ptrace in an infinite loop. And this is causing communications with the command line to time out, and that's why it's dying.
Uh-huh.
And then they have a list of extensions they've done to ptrace to make it work better. And they talk a bit about how FreeBSD introduced some of these ptrace flags, such as the ext state request that operates on a full or partial xsave data. If the buffer provided is smaller than necessary, it is partially filled. And additionally, the get x state info is provided to get the buffer size of the CPU, and so on. And then they talk about their future plans, which include add support for FPU register support, support xsave opt, and so on registers in core files, and add support for the debug registers in i386 and AMD 64.
Mm-hmm. And they close that this work was sponsored by the NetBSD Foundation, and that the contributions to that foundation will sponsor part of this work.
Yep. Then we have another post from our friend Chris Seiverman over at the University of Toronto, and he says, V7 Unix programs are often not written the way you would expect.
Huh.
So if you remember, we talked a bit about this in a previous episode about how the V7 version of ed, the editor, read its terminal input in cooked mode one line at a time, which he says, which was an efficient, low CPU design that was important to V7's small and low-powered hardware. Then in the comments, somebody pointed out that I was actually wrong about part of that, namely about how ed read its input. So he went to the V7 ed source code and read input from the terminal, and you see it's actually calling read of a single byte, and then here, and then from get tty, it was calling get character until it was a new line. Mm-hmm. So here he says get tty reads characters from get character into a line buff array until end of line, or it runs out of space. In one way, this is surprising. It's very definitely not how we'd have written that code today. And if you did, many Unix programmers would immediately tell you that you're being inefficient by making so many calls to read. And you should instead use a buffer, instead of reading one byte at a time. For example, though, if you use standard IO's fgetS, very modern Unix programs do character at a time reads from the kernel, partly because on modern machines, very few programs read character at a time because it's not very efficient. So it may have been comparatively less inefficient in V7 Unix on a PDP-11 if, for example, the relative cost of making a system call was lower than it is today. My impression is that may have been the case. So V7 has the standard I/O library and more or less its modern form, complete with the fgetS call. V6 had a precursor version of standard I/O and buffered I/O. And you can see there's the man page for getC. However, many V7 and V6 programs didn't necessarily use these. Instead, they used the more basic system calls. This is one of the things that often gets the code for early use programs their unusual feel, along with the short variable names and the lack of comments. The situation with ed is especially interesting because if you go back to V5 Unix, ed appears to have still been written in assembly. So there's ed1.s, ed2.s, and ed3.s, where S1 is the version 5 source. In V6, ed was rewritten in C and created ed.c, which is still part of the source tree called S1, but is still using that same read-based approach that I think will be used or was used in the assembly version. Okay. So I haven't looked forward from V7 to see if later versions were revised to use some form of buffering from the terminal input. But as a sidebar, he actually found an unusual feature that's part of ed. So reading this section of the source code for ed taught me that there is an interesting, undocumented, entirely characteristic little odd behavior. Officially, ed commands that have you enter new text have the new text terminated by dot on a line by itself. Right? Like if you see ed new file A, this is a new text that we're adding, and then dot on a blank line. This is how the V7 ed manual documented it and how everyone talks about it. But the actual ed source code implements this on input using the getTTY function. So if the first byte of the line buffer is dot and the next byte is a null byte, then it returns the end of file. In other words, it turns a single line with a dot into the end of file sequence. The consequence of this is that if you type a real end of file at the start of a line, you'll get the same behavior, thus saving you one character. So just press Control D instead of dot and then enter. This is a very V7 Unix behavior because of the lack of documentation. This is also a natural behavior in one sense. A proper program has to reach the end of file here in some way, and it might as well do it by, ending the input mode. It's also natural to go on and try reading from the terminal again for subsequent commands. If this is a real and persistent end of file, for example, because the PTY is closed, like if you close an SSH session or whatever, you'll get an EOF again and eventually quit. So V7 ed is slightly unusual here in that it deliberately converts dot by itself on a line into the EOF character instead of signaling this in a different way. But in a way, that's also the simplest approach. If you have to use some signals for each case, you're going to treat them the same. You might as well just use that same byte. So modern versions of ed appear to faithfully re-implement this convenient behavior, although they don't appear to document it. I haven't checked with OpenBSD, but both FreeBSD ed and GNU ed work like this in a quick test. I haven't checked their source code to see if they implement it in the same way.
Okay, that's interesting.
Yeah, some source code spelunking there,
eh? Yeah. I mean, this has been built on the very, very early Unix versions. Of course, there were no buffers and caches and things like that.
Yeah,
that
but
we
it's
now take
interesting
for
to
granted.
think that at some point, calling read one character at a time in a loop was more efficient than
on those
doing
systems.
other calls.
Mm.
And when you had very little memory, you didn't want to buffer up a lot if you could avoid it, I imagine.
Yeah, so there's the trade-off of reading more. It's time for the Beastie Bits of this week. We are starting with some interesting things. CarolinaCon 15, writing exploit-resistant code with OpenBSD. This is about a talk they gave.
Yep, by Lawrence Joe. I think we might have interviewed somebody from Calyptix after I met them at the New York City BSD Con, which must have been 2014 or something.
Oh, could well be, yeah.
Yeah. Anyway, so they talk about how OpenBSD is renowned for its security innovation and code quality, and they have some slides talking about it. So with its emphasis on exploit mitigation techniques and rigorous development process, OpenBSD provides a rich platform and environment for developers to create robust software. In particular, they talk about how OpenBSD is actually kind of hostile towards the program you're writing. But by writing your program to work within that, you gain security.
Yeah, and they have a bit of overview on how to start writing the proper way your code and structuring it. And yeah, that's a good overview. Oh wow, that's a long presentation. A lot of slides.
Yep, lots of slides, and there's a video as well.
Mm-hmm. Cool, definitely worth watching it. And you can't put enough security into your program. So there might be some tricks in there for the programmers among us. Next up, we have a call for testing the FreeBSD package base. So this second attempt, I would say.
This is a slightly different package base.
Yeah.
So yes, Chris from IX Systems has announced a call for testing for their different package base. So this version is actually built in ports. So rather than adding stuff to the source tree to be able to build packages out of it, they put the infrastructure in the ports tree to then reach over and basically build bits of the base system as packages.
Mm-hmm.
So it builds a lot fewer packages. I think it's like 6 or something packages rather than the 700 or something that the previous package-based experiment was doing. But they'd love to have your help. They have some test images available for you to try out. So basically, the test images are stock FreeBSD. So it's not TrueOS or any of their fork. It's just vanilla FreeBSD. But you'll be able to perform updates to the OS by just using the package upgrade command. Rather than trying to answer all the questions as part of the announcement, they have an FAQ page that talks about it. And they're also advertising that they're having a working group. So if you're interested in the developer side of this and are attending the FreeBSD Developer Summit, then you can look at the package-based working group as well.
Yeah, or by the time this episode will air, this has already been done. But then you can look at the notes that they take during the sessions. So that's also be interesting.
If you're interested in this, but you should also check out, they have, if you haven't looked already, the call for testing for the updated ZFS port. I think by time you watch this, the newer version will be out that includes the trim support.
Ooh, exciting. There's a lot of new things coming down the road.
I learned about that yesterday. I need to go update my slides for BSDCan to mention that. Because they say we're going to have to wait for trim instead of there should be an ISO for trim this week.
Cool. Very nice. Yeah, so test this and give feedback as much as possible. So that way they know that they're doing the right thing or can fix the bugs before they become bigger. Then there's more cool stuff coming from other BSDs. This case, Dragonfly BSD. They have initial fuse support now. This is nice. And they list
I don't know
commits.
if it's based on the FreeBSD one or not. It'd be interesting if it is, just because we'd be able to take their fixes and pull them back into FreeBSD.
Mm. They say that it's not complete, so it isn't built by default, but check the commit for details. And I guess they are moving towards a stable and almost finished or finished version even towards that. Very nice to have that on Dragonfly.
And they also announced that they have 2 significant bug fixes in Dragonfly 5.4. So in particular, they say 2 important fixes have gone into the master branch and into the stable release. The first is a floating point bug related to a long time known hardware issue with Intel CPUs. We thought we had fixed this bug long ago, but it turns out we didn't, so we needed to fix permanently with the removal of one of the remainders of the floating point switching heuristic. If you do not want to update, you can just set the sysctl mockup.npx FPU heuristic to 1, and then it will be forced to the new default instead of trying to auto-select. The second bug is related to mmap's map stack feature, which a number of interpreted languages use, in particular Ruby. The kernel was not handling several of the cases properly. In addition to fixing those cases, we have also basically stopped allowing user programs to create grow down segments in memory. We do this by converting map stack into a normal anonymous mapping. The grow down feature will ultimately be removed entirely, as it is not really applicable to 64-bit systems, but because the release threading libraries will assume that the main user stack uses this mode, it will be another 1 or 2 release cycles before we actually scrap it completely. Since this fix requires updating sources and building and installing a new kernel.
Okay. But it's well worth doing that to get those bug fixes. And then we have a Libretto 100 CT with 166 megahertz Pentium, 16 gigabyte compact flash, and 32 megabytes of RAM running OpenBSD over at Reddit.
That is a thick laptop.
Oh, wow. Long time ago. But yeah, seems to boot fine. And according to some of the people commenting, there's more in retro battle stations for gamings.
Interestingly, somebody in the chat room pointed out they don't see a trackpad or a touch point or anything. So I guess you had to plug a mouse into it. Yeah,
it seems like a very special version.
Apparently,
for
somewhere just underneath the Intel logo, there is some kind of pointing device.
So you move it with your thumb?
Yeah, you hold the side of the screen with your thumb, apparently. That's weird.
Well, they were still experimenting with the right way of using the user interfaces of tomorrow.
But apparently they run OpenBSD on it and it works.
Cool. See, it's still worth for something to keep the old hardware around.
Yep.
All right. Let's leave it at that. Time for feedback and questions now. And as always, if you want to have us answer questions in the future, then send us questions. Anything that you have about the show, comments about BSD World, ideas that you have, anything that's related to this category, send this to feedback@bsdnow.tv. Like DJ did with feedback that he has, goes like the following. BSD Now team, thanks again for the great show. Responding to your request in episode 294 for feedback on killer BSD features that BSD users miss when using Linux. How about sane package/port management? Yes. This is what originally convinced me to switch away from Linux in the early 00s. I'm still enjoying these aspects on all major BSDs today. This varies per BSD flavor and Linux distro, but BSDs generally have mature, unified repositories, clearly based on mainline source code for various projects. This comes along with usually simple patches, easily configurable options, and trusted binary packages. Dependencies and upgrades are generally managed reliably. It is nice to have one trusted repo with all compatible ports packages maintained.
Yeah, I remember having come originally from FreeBSD and then looking at some of the other Linuxes like Ubuntu and so on, and being like, I have to add other repos? Who manages these repos? They're not from the project itself. They're just random people's repos. Why would I want? That's confusing.
And I need to edit a file each time, and I need to get differences between stable and updating and testing. And seeing that as a difference is definitely something that will draw you to the BSD. So, and we can't thank the ports people big enough, because they're doing all that work for us to make it easy for us to use these systems and run ports and install them. And alas, also, since ZFS arrived in FreeBSD, in the rare instance when something bad happens in package management, then ZFS to the rescue. Snapshots or boot environments make it easy to recover from a bad package or install upgrade. ZFS on Linux may now be taking the lead, but actual practical benefits like this are still not easily achieved in most Linux distros yet, if I'm not mistaken. Yeah, with the common source now different, that will be less and less of an issue, I guess.
Well, Linux still hasn't figured out how to boot from from ZFS nicely yet. So
yes, there's still the licensing things that make it difficult.
It's not even necessarily licensing; it's just Grub is not well suited to it. And
Okay. So that being said, DJ continues. Linux has some other developments maturing, like Snap, Flatpak, and App Image, each with unique trade-offs.
Yeah, what's interesting about most of these Snap and Flatpak type things is, do you know what they remind me of?
Some
PBIs.
BSD thing? Yeah.
The PCBSD package thing where every package was fat and bundled its own copy of the dependencies so that you wouldn't have conflicting dependency versions and stuff. But we found a lot of problems with those and instead moved away from that. And now it seems everybody's back to this idea of multiple overlapping disk images with the stuff in them.
Yeah, the learnings were there definitely. So I guess people should look at other systems and who went through this phase and maybe learn something before they do the same mistakes all over again. And possibly cross-platform compatibility that may be coming to BSDs in the future. Linux presumably can use package source. I wonder how that's doing post systemd. And FreeBSD...
systemd doesn't really affect the package manager. It can affect some of the applications, but again, package source is basically just a version of ports designed to work on OSs other than just FreeBSD. And so...
maybe it's the startup scripts. If you run like an...
But like in general, if you install something like, say, Mate, it just looks at your system, sees what type it is, and does whatever that type likes. And it's, you have systemd, I'll use this script, and if you have not systemd, I'll use that script or whatever.
That would be certainly part of package source. FreeBSD may have new jail-based solutions, likely more elegant than entire containers. These things may all be worth watching in the near future, whether you use Linux distros or BSDs. Yeah, I guess.
Lots of interesting things might happen.
Yeah, a lot of people are working on interesting things. Some are a little more closer to being finished or being put into the public than the other ones. But there's always interesting things coming down. That's why we have a news show about this, by the way. Okay, thanks for that question. Next up is Fabian about ZFS Arc. Oh, Alan gets interested. Okay, so goes like this. Hi, Alan and Benedict. I'm considering installing FreeBSD on a laptop with 4 gigabytes of RAM. It would be nice to be able to utilize the features of ZFS, but I'm a bit concerned about the memory usage. How is the memory shared between applications and the Arc? Do I understand it correctly that the Arc won't give up any of its space when other applications need more memory?
So the Arc will give up its space. Sometimes it's a few 100 milliseconds slower at it than you would like, but
in general,
it will give up space.
Yeah, it's greedy and generous. It gives memory back.
Well, yes, it's greedy within the limits you set for it, and then it can just take some convincing to make it give the memory back.
So he has heard that you can set the maximum Arc size through a sysctl, but when the Arc is mostly empty, will other applications be able to use the memory if it isn't being utilized by the Arc?
Yes, and you can easily see this if you just run top. You can see the size of the Arc versus everything else. Now, the Arc will almost never be mostly empty, except for when you first boot up. The Arc has its maximum size, which is usually also its target size. And since it's a cache, it will keep data you've read or written in memory to make it faster when you access that data again, forever, basically. And it will replace it with newer data when you read or write newer data. But it tries to keep some of the most frequently and most recently used data available in memory so that when you go to use it again, because your most frequently used and most recently used data are the ones you're more likely to use next. So it makes the system faster. So you're going to want to set the limit, especially in the laptop case, to something reasonable. So he asks if 512 megabytes is reasonable. Yeah, that should be fine. In the end, it's a matter of what else you need memory for. And with only 4 gigs, if you're planning to run a web browser, you're going to need more than 4 gigs as is, right? So you don't want ZFS taking too much of that. But then he asks, how do you expect the read and write performance to compare to UFS? Well, the more Arc you give ZFS, the better it's going to compare. But in general, it shouldn't be too much different. Now, reading can be better or worse depending on some factors. For example, in UFS, when you overwrite a file, it's going to write it to the same place. So if you change just the end of a file, it's probably going to end up in the same place as the file originally was. And so the unchanged part of the file and the changed part of the file will still be side by side. So when you read them, it'll be a straight shot. Although if you keep appending to a file, it might end up in slightly different places. With ZFS, every time you write all of the data that was written around the same time in a big chunk, kind of like your log style file system, right? And so that means when you read a file that you modified, because you don't overwrite it in place, you write it as new data at the end of the log, that if you try to read that file, you're going to read the beginning from here, the middle from here, and the end from here, and it might have slightly higher latency. Now, ZFS read ahead can use the Arc, where when you're reading that first bit, it can have the hard drive already going and fetching the next bit and keeping it in the Arc so that when you ask for that next, which it predicted you were going to do, it can give it to you faster. So ZFS uses the Arc to try to hide some of the complexity of the fact that it's copy on write and avoid some of the performance penalty there is to that. If you have less Arc, it will be less able to do that. But in general, you're probably not going to see that much of a difference on read performance. The write performance on ZFS could actually be better for 2 different reasons. A is compression. If you write 100 megabytes of data to UFS, it will have to write 100 megabytes of data to your disk, plus some metadata. With ZFS, it's going to first try to compress that 100 megabytes. Maybe it compresses it down to 70 megabytes. And then there's some metadata. The metadata is a little bigger in ZFS, but that's not really that big of a deal because it compresses as well. So now ZFS only had to write 70 megabytes to the disk, because it compressed that 100 down to 70, which isn't even that high of a compression ratio. So if you assume your disk can actually do, say, 100 megabytes a second, which is probably pretty fast for a disk, ZFS now took 700 milliseconds to do it, where UFS took a whole second to do it. And the second thing is that fragmentation thing. UFS, if you're writing to 4 different files, those 4 files might be in different places on the disk, and it's going to go write some here, and then move and write some there, and move and write some here. ZFS is just going to take all of that and write it as one big continuous string, unless you don't have a contiguous chunk of free space, then it'll have to split it up. But so ZFS might actually be able to write faster, not just because compression means it has to write less. And same for reading, right? When you read back that 100 megabytes you wrote compressed down to 70, ZFS only had to read 70 megabytes, and UFS had to read all 100. So it's very hard to say how the read and write performance is going to compare. It really depends on your workload and the type of data and how compressible it is and how fragmented it is and what your hard drive is like and on and on and on.
Don't forget the boot environments.
Yes.
It's not I/O,
but the advantages of ZFS are going to outweigh all the disadvantages. So yes, go ahead, use ZFS on that laptop.
That can only be seconded. So thanks for watching the show and sending us that question. And hopefully you have a lot of fun with your laptop and either ZFS or UFS on that. Okay, next is Caleb with a question. Hi, Benedict and Alan. In a recent episode, there was a discussion praising the flexibility and utility of standard Unix tools that concluded with what I'll summarize as, for data processing tasks, sometimes it is better, cheaper, faster to use these tools than specialized ones like Hadoop. My question is, what workload characteristics might cause you to consider one of these special solutions like Hadoop instead of powering through with the shell? If you have any stories about a time when that you could share.
So my first thing is I've never actually used Hadoop, so I don't know. Now, Benedict teaches some big data classes, so maybe he'll know better. I'll get to that in a sec. Some of the advantages I would foresee is depending what kind of data you're analyzing and for what, there might already be pre-built templates or whatever, things like that for Hadoop that's going to do what you want. And so you just feed the data in and you get the result you want out. Whereas with a custom shell pipeline thing, you're basically always going to have to build it yourself or maybe find something somebody else built and then adapt it. But it's very much you're writing your own data processing solution for each different input, whereas something like Hadoop is maybe built to do that. But it can depend on a bunch of things. So, my thing was based on a presentation I saw at BSD Cam one year where feeding all the data into awk and some shells stuff only took 7 minutes, whereas doing the same operations to it through Hadoop took 40 minutes. But if it took you 40 minutes to write the shell and 0 minutes to write the Hadoop, maybe the Hadoop would have actually been faster in the total time or total cost of ownership kind of thing.
Yeah. So you have to know your data, what it looks like. If it's different each time and you have to process it, then it's going to become cumbersome. But if you have standard data processing, then look at Hadoop. Of course, it's one of the big solutions out there. The problem is when you're processing data with Hadoop. So Hadoop has this DFS, the distributed file systems, across all these nodes that you have. You can also run Hadoop on a single node, but that didn't get you much. So you have this DFS where you first have to put the files in. So there's these HDFS put commands and there's some ls commands. So it's similar to a real file system. And then once the data is in the HDFS, Hadoop can make use of it by spreading it out among these nodes. And then you have to write either a job or some kind of MapReduce job to process all that data across these nodes, to actually make use of the data, to pull it out or summarize it or aggregate it in the way you want to have it. With Unix, you use pipes and the Unix tools that you have handy that are already installed, like awk and grepset, whatever you have, and that makes it easy. But this is just on a single machine. You first have to do the networking. That's the big point.
Is if your big data job is actually not so big that you can't just do it on one machine, it can be a lot more efficient to just do it with the shell than having to build out a cluster and a distributed file system and doing it. In the example here, the one I used with the 40-minute Hadoop job or whatever, they had, the storage was here and the machine was here and they had a 10 gigabit connection. And so they basically fed the data into awk and then wrote out temporary files and then for each stage. And because their storage was fast enough, they could do this quickly enough. Whereas, so it took very little memory, right? Because they could just do temporary files as steps and keep reducing it down as they went across. Whereas Hadoop was going to have to try to keep big tables in memory and deal with this. And for some jobs, you need something that big. But sometimes you just want to process this one log file or whatever, and it's not so large that you actually need to distribute it across 6 machines to get it done.
Yeah.
Sometimes it is. And so, maybe the easiest litmus test is this job so big it's not possible to do it on one machine? In that case, then the shell gets infinitely more complicated, and maybe Hadoop is the right answer.
Yeah. And I mean, there's also a big Hadoop ecosystem that's building on top of Hadoop, or some other NoSQL databases that are specializing in certain things like document-oriented processing. That it's more difficult to do it on the Unix shell. For that,
and
could work.
Sometimes, because even though this job isn't big enough to need Hadoop, it might be useful for you to learn Hadoop to be able to handle that bigger job when it comes up. So we're not saying never use Hadoop. We're just saying sometimes, especially if you only want to do like a simple thing, the process of setting up Hadoop could be much too big.
Yes. And I mean, most people just recommend it out of a because they have heard it before and don't even look at the simple utilities from Unix. They just say, oh, it must be done with Hadoop because that's the processing solution. But if you look at the Unix tools, then you can basically say, well, they are doing the same things and they have been doing that for years and have flashed out all the bugs in there. So just a little bit of pipes in between those could get you already halfway towards where you want to be. But that pretty much is...
hopefully one thing that might come out of this new Windows subsystem for Linux thing and the fact that they're expanding that with WSL2 might actually be that more people will be familiar with the basic command line tools like, awk, grep, sort, etc.
Yeah, it's available then, and you have it in your little tool chest on Windows, and there may be a resurgence of these tools that may be becoming more popular even on Windows, and they're being integrated in Windows solutions being built on that.
More people will have heard of them this way, and maybe that will mean fewer people assuming that they're going to need a big tool when maybe it turns out there's a small tool that's been around the whole time.
Yeah, exactly. All right, before we wrap up, we have a small programming note for you, like we mentioned in last week's episode. After BSD Now episode 300, we'll change the podcast a little bit. So we'll switch to audio only with newer, higher quality audio recordings and production systems so that Alan and I will provide the same kind of podcast that we always provide. But
it'll just sound better.
Yeah, you'll definitely get a bit of audio quality improvements. We're not overlapped too much with our comments on each other. And for the people who still want to look at Alan's Tetris blocks from week to week, there's still the live stream, which will likely include video, and the rest of the podcast that will be released at the end of the week, mostly, will be audio only. So that's the big change.
Currently, more than 80% of our downloads are the audio only version anyway. So for most people, it will just mean the audio will be better quality now. But for the few people still loving the video, after 6 years of doing this, it's everything I can do to make it take less time is better.
Yeah, and I mean, a lot of people watch this on their commutes or in the car, and they don't even have. They just listen to it and don't have any videos there anyway. And you shouldn't watch video while driving anyway. So that's what podcasts are, and we'll do audio only from episode 300. And that wraps up episode 299. So that is almost on the verge of happening. So thank you for watching, and see you next time. Or here.
See you next time.